So what is our question? Our question in this case is going to be, what does the limit of x approaches to our infinite values of f of x, and what is that f of x? That f of x is going to be 5x squared minus 2 over 3x squared plus 8. So what is this question about? Well, we know that this question is obviously going to be the question about the function. And how do you know that this question is basically about the function? And we can think about its definition and its properties. Well, what is the function? So what is the function where we usually note it as the f of x? Well, the function is a system of patterns that always should require a specific input, where we call it or note it as the x value. And since we have that x value, what should we have? Well, we input some values, and what should we have in the eventually? We need to have a specific output, since we inputted our x value. And what do we call as our output value? We note it as our y value. Well, we know that the input value, x value, and the output value, y value, is the most important thing in our function systems. Because we know the function, we usually note it as our f of x, and the f is generated from our output, and our x value is generated from the x value. So using these things, that is a main thing that requires or creates our main function. So this is the thing that generates our function. But what function exactly is the thing that should be a main priority in this question? Well, we have talked about this in the previous video where we talked about the limits, but we have talked about that almost every single question about the limits, almost every single question about the limits in our function system, we always need to apply this to our, what was that function? That rational function. And people might think that, what is our rational function's definition? Well, let's think about the definition of our rational function first, before we actually apply this to our original question, because rational function is the most important thing in our limit section. So what was the definition of our rational function, which we'll also note it as our f of x? So our definition of our f of x, which we'll call it as our rational function in this case, is going to be a function. Types of our functions. So any types, it can be any types of our functions where it is formed by a fraction. This is the most important thing in our rational function. What is a fraction? It is a stuff that is formed by numerator and denominator. And next thing that we need to pay attention is that the numerators in our fraction and the denominators in our fraction should always be what? It should be a polynomials. This is the main definition of our rational function. So any types of functions formed by fractions, so that function should formed by a fraction where the numerator and denominators are polynomials. Now we might need to think about what is the definition of the polynomials. There are lots of things about the nomials. So there are a lot of versions of our nomials. There should be always more than 0 of our nomials. So this is what the definition of our rational function is going to be. And we know that our rational function is the most important thing in our limit systems. So that's why we have talked about the definition of our rational function. So basically, we're trying to solve for our question limits. So our actual question in this case is going to be, so our main question in this case is going to be solved for the limit. What about the limit when the x value or input approaches our infinite value, and of our 5x squared minus 2, all of them, over 3x squared plus 8. We're going to solve this value. And if you need to solve this value, we're done with this question. And if you want to think about solving this question, we need to think about 3 things that we need to know in order to apply this question. And I have wrote it in right over here, just 3 things. And the first thing that we need to talk about is the definition and types of our limits in our rational function. So, and the limits should be the key point in this question. So the first thing that we're going to talk about is the definition of our limits in our rational function. And the definition of our limit is going to be, limit is a value that a function or sequence approaches as the input value, which is our x value, approaches undefined values. So from the definition, we might think about also the types of our limits, also, which means it is a cases of our limits in our rational function. And the limit is a value that a function or a sequence in our systems of arithmetic approaches as the input value. What is our input value? It will be x value, approaches our undefined values. What is the undefined values? They are the values that the answer is going to be 0, that it can't be defined. So it can't be defined. This is what the undefined values means. And from the two types, there will be a function and a sequence. That means we can apply our limits to either the function or the sequence in our rational function. So the first thing that we might talk about is what the formulas, the different kinds of formulas of our limits when you apply our limits to the functions or a sequence. So for the function of our limits formula for our limit when you apply to our function system is going to be the limit when the x value approaches our some values, and we're trying to solve for the f of our x value. So we're trying to solve for the f of our x value. This is what the function for our limits values or the formula is going to be. And let's think about the second one, where we need to think about the formulas for our sequence. And for the sequence, for the definition of our sequence, it is the same thing with the set of numbers that should always satisfy its own patterns or equations. So the sequence limits is going to be the limit when the a value approaches our infinite value of a of n. This is what the sequences formula for our limits is going to be. And if we add all of these situations over the number of possibilities, we will call it as the limits. This is what the formulas for our limits is going to be, and there are two cases, function or sequence. And the main difference between the formula of our function and our sequence will be different by the input values. And our output values. And for the function's input value, we call it as the x value usually. And for the sequence value, it will be numbers or the values except for x. And for the output value, which is the most important thing in our function systems, for the function we will notate it as the f of x, but for the sequence we will do it as the a of n. And obviously a of n, f of x, they're all going to be variables, which means they should always vary or changes depends on times. So these are what it is to be a formulas of our limits in our rational function. And this was the types of our limits. But this case it is a little bit different because of our question. Because this question has obviously going to be a question about the function systems, because we see a variable x value which shows an input in our function, but the main difference between the original one is that the x value is approaching our infinite value, not a normal values. So there are two types of our limits, and there are also two types in our function values. So let's get through our two types of our function values of our limits in our rational function. So this time we're going to talk about the types of limits in our functions, and then what is that function is going to be. It will be a rational function that is formed by a specific polynomials in our fraction systems. And the difference between our limits values in our function will be different. What will the different amounts going to be? They will be different by the values of values of our x value approaching. So there was main difference between the limits of our function and the sequence. There are the variables, and also the values of the x value input value approaching was different. And in this case, there are also two cases in our limits in our function, especially in our rational function, and they will be different by the values of our x value approaching, not a x value, the x value that is approaching. So this will be different by the values of our x values approaching. So we might have the two equations for it. And the first thing that will be my talking about is there are two cases. And the first case of our rational functions limit system is going to be, first case is when the limits of our x value is the approaching the value. I will call it as the m value because it is a variable that should be less than a infinite values. So it should be less than infinite values, and the f of our x values. So this means it is a rational function where the x value passes through the values that is less than a infinite value, and these numbers, the n value, it will be different by the x values approaching numbers. And when the x values approaching numbers, which we'll call it as the n value, is less than an infinite value, this will be a first case. And these values of f of x, what we need to do is we need to factor the numerators and denominators, which we'll call as the numerator divided by the denominator, and this will form a specific fraction, which will form a rational function, which is the most important thing in our limit systems. So this is what we need to do in order to solve for our limits. And the first thing that we need to do is when our limit value, which is the x value, when the x value and the number that is approached by the x value is less than infinite value. What we need to do here is factor the numerator and denominator together to get what the answer for our f of x, which is our y value of our x value is approaching. So this is the first case of what we need to do. We need to factor them out in order to reduce them out and solve for our f of x. But the second thing that we might talk about is the second case. But the second case is a little bit different. It is a case where our limit value, where our x value is approaching for the n value that is exactly equal to our infinite value, and then f of our x value, which is our y value. Then what we need to do is we need to solve for the asymptotes. We are thinking about the new concept in our rational function, which we call as the asymptote. The asymptote of function. All you have to do is solve for the asymptote of our function. If you have that, the x value approaching our exactly infinite values. So the asymptote of our function. But what is our function in this case going to be? Well, the function in this case is our f. We'll note it as the f of x is equal to when the limit value, as the x value is approaching our infinite value of our f of x. And what is the f of x? The f of x is 5x squared minus 2, all of them, over 3x squared plus 8. This is what this value is going to be. And this value is going to be the asymptote problems. And the reason why we can see that this is a asymptote solving problem is because of the approachment of our x value. The x value, which is our input value, is approaching our infinite value. That's why this question is about the asymptote values. And as we need to remember that there are two cases in our limits when we apply to our function, where it can be either the number of our x value, where the n value is less than infinite, where the x value should always be exactly infinite values. But in this case, this question is basically about solving for the asymptote of our of our rational functions. So before we think about applying all of this that we know in our knowledge to our rational function, we need to know what the asymptote is in our rational function. And that will be the second thing that we need to know in order to solve for this question, which is the definition and the formulas of our asymptotes of rational function. We'll be talking about the definition of our asymptotes in our rational function and its definition of our asymptotes in our rational function, which differs from the function that is continually can be factorable, where the x values approach number is less than infinite numbers. And the definition of our asymptotes is the asymptotes in our rational function is going to be like something like this, that it is a straight line. It can be either line or a curved line that continually, and if you don't know what the continually means, that means it is a line that continues, that means never ends in some place, keep going, and it approaches a given curve. But the most important thing in our asymptotes is it to never intersects together. This is what it means by its asymptotes. And we usually notate this as the rational function's asymptotes. And since we think about the definition of it, we need to apply this to our coordinate plane to give us or remind us what the actual asymptotes definition is going to be. And we need to think about the formula and apply this to our original question. This is a coordinate plane that is formed by the horizontal and the vertical axis, and let's say there is a given curve that looks something like this, and this is just an example, and the values of the asymptotes can be changed. What are some possible asymptotes of this curve? Well, it can look something like this. The asymptotes of this curve that can look something like this, and this is just an example that keeps going closer. That is this line is getting approached to our curved line but never intersect together. And what are some other asymptotes that can possibly be? Well, this line can also be a asymptote where it keeps going on continually to approach to our curved line, but it never intersects together. So we will call these lines as the asymptotes. And we will talk about why we need to use our asymptotes in our rational function later. And this y line, we also call it as the asymptotes in our rational functions. And this was the definition of our asymptotes in our rational function, and kind of a visual proof what the asymptotes was on our coordinate plane. And all you have to do is solve for our original question. And what was our original question? It is limit when the x value approaches to our infinite values of f of x. And what is the f of x is going to be? It will be 5x squared minus 2 over 3x squared plus 8. So if you write it down again, the limit when the x value approaches our infinite value, and the f of x is going to be 5x squared minus 2 over 3x squared plus 8. And before you think about how to solve this question, there's one more thing that we need to know. The one more thing that we need to know is formula of our asymptotes. Formula of our asymptotes in our rational function. And obviously this asymptotes is the most important thing in our rational function, so we will always start our asymptotes formula from our general format or formula of our rational function, and we need to prove why they are the asymptotes formula. And what is the standard form? So what is the standard form, which is the basic format and of our rational function. Well, the standard form of our rational function, which means it is the most basic format of our rational function, is going to be every single function starts with our f of x value, and that f of x is going to be x plus d divided by, so we can just say, let's just say ax plus b, all of them, over cx plus d. This is a standard form of our rational function. The f of x is equal to ax plus b over cx plus d. This is a standard form. And the formula, or the formula of our asymptote was originated from our standard forms formula, or the general form. And what is the form? What is the standard form, or the formula for our asymptote is going to be? Well, if the formula is ax plus b divided by cx plus d, the asymptote formula is going to be a over c. A over c is going to be a formula of the asymptotes in our rational functions. And if you write it down again, not to be confused about it, the formulas for our asymptotes is going to be a over c values. So using this value, we will be able to solve our original equation. And if you write our original equation down again, the limit when our x value approaches our infinite value and our f of x, what is the f of x? It is 5x squared minus 2, and divided by our denominator, 3x squared plus 8. So this is our main questions. And as we can see, there were two types of our rational functions limit, and they will differ by what is the approachment of our x is going to be. And there are two cases where the value we'll call it as the end value is less than infinite value, and it's exactly going to be infinite value. And this is exactly going to be a infinite value where the x is approaching. So that means this value should always have the asymptote. And what is the formula for asymptote is going to be? It will be a over c. So a over c is going to be what the asymptote is going to be. And what is our a value? A value is going to be the top x coefficient of our x value, which is the 5. And what is our c? C is a coefficient of the x squared term in our denominator, and it will be 3. So what is a divided by c? A divided by c is 5 divided by 3. So 5 divided by 3, which is our total answer. So our answer for this question is going to be 5 over 3.